So today we're going to talk about linear equations, something you've done in 8th grade where you talk about y equals mx plus b versus linear functions in 9th grade where the y is replaced as a function of x equals mx plus b. So we're going to take a look at both of them. You should have taken a couple of minutes to fill out what you already did in 8th grade. We're going to focus in on 9th grade linear functions. So f of x simply replaces the y in the equation y equals 2x minus 4 as shown above. Okay, so function notation just tells us the name of the, in this case, the name of this function is f, and the algebraic rule. So whatever comes after it is the algebraic rule for the name of that function it'll be using. So you're going to note any letter may be used to name the function. So it doesn't have to be F, it could be G, it could be H, it could be T, it could be I, it could be Z, it could be any letter of the alphabet is used to name the function. All right, so let's take a look at a function and just break up each part so that you can understand it. Again, the difference being in 8th grade, you would have said y equals 2x minus 4. Now we're going to talk about function notation and what it means in detail. All right, so let's look at f. We've already kind of talked about f is the name of the function. Okay, so we're going to fill that out right here. So f is the name of the function. Okay, x is the input value, the independent value. What that means, so this is input. Independent means that it doesn't depend on anyone. It's an independent person, right? It doesn't depend on anyone at all. So it's what you are putting into the function. So you're going to put x into this function f, and you're going to get an output, which is actually what we're going to do next. So this is going to be output value found after plugging in the input after the equal sign. This is the dependent. So this is called dependent because this output is dependent on the input x. Because to get this output, you're going to take 2 multiplied by the input. So it depends on the input. Whereas the input is independent because it does not depend on anything. So what you're getting out of the function is what comes after the equal sign. All right, so now let's take a look at what you did in the 8th grade answers for questions 1 to 3 and make it 9th grade math. Okay, so we're going to take a look at what you answered and we're going to talk about it just to make sure you answered it correctly. The question is, how much ice cream was left 10 minutes after Jordan got the cone? All right, so let's go see what's going on. Jordan bought an ice cream cone for 3 days in a row and sat outside to eat it. Each time the cone began to melt at different rates depending on the weather. The cone is melting each day as described before. Match the graph with the day that it likely represents. Okay, so let's talk about that. Day 1, it's cloudy, so the cone barely melted at first, but then the sun came out and it started melting quickly before getting cloudy again. So let's take a look at our options. It's not melting. This one is melting. This one's not melting. Then it starts melting. Then it's not melting. So this is going to be day 1. So that's day 1. So let's read the rest. Day 2, Jordan moved into a sunny spot which caused the cone to melt. Okay, so this is melting. This is also melting, but it's melting very quickly. Jordan got too hot and went inside to cool off. So it's melting and then it's cooling off. So this is also melting and looks like it's cooling off a little bit. So let's read day 3 and see if it gives us clarification between the difference. It was sunny and hot. The ice cream melted steadily. Okay, so that word steadily means at a constant rate. And we've talked about linear functions or linear equations. So this will be the constant rate. So this is going to be day 3 and then this one's going to be day 2. Okay, use only graph A to answer the following questions. And again, the questions are the same because they're right here in 8th grade. How much ice cream was left 10 minutes after Jordan got the cone? Only on graph A. So 10 minutes. So if you look time in minutes, ice cream left in ounces. 10 minutes, there was 1 ounce left. So here we said 1 ounce. Okay. And again, these questions are the same. How much ice cream was there when Jordan first got the cone? Okay, so when no time had passed, 0 time had passed, it was, does that look like 6 or a little less? A little less than 6. So let's call this, it looks like maybe 5.8-ish. Okay, so this is 5.8 ounces. And again, we're going to transfer the 8th grade into 9th grade, so we're going to put it in both spots. At what time did Jordan have approximately 1.8 ounces of ice cream cone left? So 1.8 of ice cream ounces is this side. So 1.8, maybe around here. And boom, he had 6 minutes. Okay, so this is 6 minutes. This is 6 minutes. All right, so, let's also finish this. Consider the statement, Jordan had 2 ounces of ice cream left after 6 minutes. Well, that's not true because we already just did. He had 1.8 ounces left after 6 minutes. Do you agree with the statement? So we're going to say no. And then we're going to say explain because he had 1.8 ounces after 6 minutes. All right, so now that we have our 8th grade answers, let's take a look at how do we now make it into from a linear equation, 8th grade y equals, to a linear function, 9th grade f of x. Okay, so write 8th grade answers for questions we did. Look at the x-axis and y-axis labels to help you figure out function notation. Okay, good. So the x-axis you can see is time and the y-axis is ice cream in ounces. So what that tells you is this. Remember, this f of x means y, and this x is the input, what you're putting in. And that's why it's saying hint, look at the x and y axis. So we know that x is your time and y is your ounces. So I know if I see time, what axis am I thinking of? Okay, I'm thinking of my x. So this one is my x, which means this is my y because it's ounces, right? All right, I'm reading the next. How much ice cream was there left when Jordan first got the cone? If you're confused about that, let's look at this answer here. This is in ounces, so that's my what? My y. This means this is my x because really it says when he first got the cone. So think about that. No time has passed. So this is really when x is equal to 0. This one, at what time did Jordan have approximately 1.8 ounces? So again, they've just switched this over. So remember, your axis says this is the y and minutes is time. So this is the x. That's going to help you translate into function notation quite easily. So now it says use AT because it's graph A and the input is time. So we're using A because it's called graph A, and T is the input because the x-axis is time. So now we're going to write all this sentence simply in function notation. So it's a shorthand of writing all these words. So how much of ice cream was left after 10 minutes? So we're going to say A and 10 minutes is time. So A of 10, because remember, it goes something of the input equals whatever the output is. So A of 10 is equal to 1. So this entire sentence, these two things right here, can be summed up in these characters right here. 10 minutes after whatever was happening in graph A, your output is going to be 1. All right, so see if you can pause the video real quick and write this out. It's very similar. Again, following AX equals whatever the value output is. Okay, so you should have written A because the function is A. What's the time that has passed? No time, which is 0, which is equal to the output at 0, which is what? 5. So A of 0 is equal to 5. Again, function notation is a way of representing all of these words in a quick, concise way. All right, now we're going to switch things up a little bit. We've got, this time we're given y, and then x is right here, but function notation follows the same rule. The function is A. The input you're putting is the x-axis, which is time. So in this case, it's 6. And that's going to give you an output of 1.8. So again, this sentence reads, 6 minutes after Jordan got his ice cream, he had 1.8 ounces left. So this whole sentence that I've just said can be represented this quickly. And that's what function notation is. Everything else is the same as what you're used to. It's just understanding the language that we're now using in 9th grade. So now that we've done that, let's go over some stuff we did in 8th grade, only using function notation. So it says evaluate and describe what each expression represents in this context. So you're going to evaluate what is A of 14. So now you have to know what that means, right? So we just talked about this. What is the 14 symbolize? It should symbolize the input. And what's the input? Time. So if time is 14 and the function is A, it means when I look at my question, I'm looking at graph A and I'm looking for time to be what? 14. When time is 14, what is the number of ounces left? 1. So at time 14, there is 1 ounce left, which means, again, this sentence means, who's this? Is it Jordan? Yep, Jordan. Okay, so which means after And there's so many different ways you can write this. After 14 minutes, Jordan had what left? 1 ounce of ice cream. And try to use as much of the information given in the question as possible left. And there's, again, 1,000 different ways for you to write it. Okay, so it doesn't matter as long as you're giving me the information. All right, let's do another one. This time it says the name is A, so look at graph A, as a function of time is equal to 3.8. So first of all, tell me what is T. So this one you're actually going to do, and then I'm going to do it. So again, you're looking at A. What's T? So go look at your graph, see if you can answer that. You're looking at the graph A, all right, and you're told A of T is equal to 3.8. What is T equal to? All right, so let me go ahead and do it. So A of T is equal to 3.8. So the input is T, which is the x-axis. The output is 3.8, which is the y-axis. So that's saying in graph A, I'm going to have an output of 3.8 ounces. And if I go to the graph, I'm going to have that in 4 minutes. So the time is 4 minutes. And again, in the new language that we just learned, what does this mean? Now I'm going to try and write it a little bit different than I wrote this, because I can write it exactly like how I wrote this and just change the numbers. I can say after 4 minutes, Jordan had 1 ounce of ice cream left, right? So instead of saying that, I'm going to say Jordan has 3.8 ounces of ice cream after 4 minutes. So again, just making the sentence a little bit different, but it means the exact same thing. And then finally, just in general, what does this mean? It means, and again, we can take any one of these sentences, we can mean at any given time, at any given time, T, right? So no matter what input you give me, I guess comma, Jordan has C ounces of ice cream. Okay, so just in general, what the statement means, at any given time, this is how much ice cream is left. Whatever the input is, whatever the output is. All right, so let's really dig into this 9th grade math. And what you are going to do is you are going to answer these questions, but now pay attention. This is function B. This is function C. So remember, these are the names of the functions. So you're going to say, in fact, let me just do one. You're going to say B. And what's the question? How much ice cream was left 10 minutes after Jordan? So is this input or output? Input. So B of 10, my input, is going to give me what? Now, which graph should I be looking at? Graph A, graph B, or graph C? Graph B. So the input, okay, which is my x-axis, is 10. So this is right here, x-axis 10. So my output is going to be 3. So B of 10 is equal to 3. I'm going to do function C as well. So C of, and it's the same question, just function C. C of 10, and again, now where do I look? I have graph A, B, and C. Okay, good. I look at C. My input is 10, so I'm looking at my x-axis. My input is 10. My output looks like it's just underneath 1. So shall we just make it 0.9? 0.9. Okay, so go ahead and complete these 2 boxes for me, and then unpause the video when you're done. All right, final question, and you can answer these statements. Determine whether the following statements are true or false. And I will do one, and you can do the rest. All right, so B of 10. I know B of 10 from this box right here. Function B of 10 is 3. C of 0, which I haven't done, so I'm just going to go look at C of 0. So here's C of 0, which my input is 0. What's my output? My output is 7. So is 3 greater than 7? And we're going to go with no. 3 is less than 7. Okay. All right. So you go ahead and complete number 10. Let's practice.